Welcome to another session, Data with Nikk. This part 4 of Spark Basis Simply Explained, and today we're gonna see the Spark architecture in action. In part 2, we deep dived into the Spark architecture and learned about actions, transformations, lazy evaluation, and job stages and tasks. And today we're gonna deep dive more into the code and to the Spark UI to really see how those different elements of Spark really behave in action. And that's also important for you later on to understand those concepts and use them for optimizing your code later on. If you haven't seen part 2, you're gonna find the link above here in the screen and also in the description below. That means for today, we're still gonna do a short recap of Spark's architecture, and then we directly gonna deep dive into VSCode and the Spark UI and really observe how those different concepts are behaving of Spark. All right, let's start with a short recap. So in the past, we learned about lazy evaluation, and the major differences, if we compare here two examples of Python and PySpark, is that if you're reading, for instance, a Parquet file is here, and then do a filter, and then perform a count. So Python is loading the data directly into memory, and then performs a transformation step by step. So whenever we run one transformation, Python is actually working. And PySpark is doing exactly the opposite. So we differentiate there between transformations and actions. And an action is where actually PySpark starts an execution. Meaning lazy evaluation means that PySpark literally is lazy here. And the transformations are all collected until a count, an action is happening in this case. And then the so-called catalyst optimizer optimizes all those collected transformations of your query engine with your query engine. And an example, for instance, could be that we have a predicate pushdown which is available for Parquet. And as we're using here only the column ID, we might not load the whole data set, but rather load only the data set with column ID, which is enough to perform the filter and perform the count in this case. So if you're looking to actions, there are way more than only a count. Examples I collect a show, first, take n. And basically what it does is actually make the data frame available. So if you're writing only transformations, we're gonna see it also in VS Code in a bit, you're gonna realize you don't have a data frame available actually. Instead, we have like the transformations, which basically result in the background in RDDs, the core data format of Spark. And we divide them basically into narrow transformations and wide transformations. So select or filter is a very easy example of a narrow transformation, because what's possible is we can parallelly execute those transformations. While for wide transformations, like for a group by an aggregate, we have to have movement between the Spark partitions. So you can imagine, for instance, in a join, we might have to check with different partitions if the mapping of the partitions is possible. So if a worker has only one partition of those two data frames, we don't know if maybe we have IDs mapped from another partition. So the same thing for an aggregate. So we cannot aggregate only on one piece of the data set if you don't know or haven't seen the data set. So those wide transformations are a little bit more complex. There we're gonna deep dive definitely in one of the next sessions. There are also like some Spark logics which are behind, which improve that, of course. Another thing which is also important is that we have something called job stages and tasks. So tasks are where the parallelization are happening, and each task is being executed by one core. So by the executor worker in our architecture. And jobs and stages usually are the sequential execution. So one or multiple jobs are generated when we have an action. And a stage, so for instance with a count, if you remember, we had a local count and then a global count. So basically after local count, the intermediate result has to be serialized and saved on disk. So, and this saving on this usually is then splitted into two stages. So we have the one stage which can be executed together with the transformation, then we have the serialization and saving of the data in the next stage. So, and also usually in write transformations, due to the shuffling operation. So shuffling means that the data has to be reordered, let's say very simply. We usually also gonna end up having at least one stage on the shuffle operations. And basically this slide sums it up. So jobs is the high level and is executed by an action. Then we have the stages which divide the job, usually sequentially, but sometimes in joins you might have also parallel stages. That's why I said usually sequential. Then you have the task. So if you have cluster, like in my computer we have 4 cores, you're gonna have 4 tasks which can be executed on those 4 cores in parallel. If you have now a bigger cluster with one drive and one or multiple workers within some 16 cores, then it can be running 16 tasks simultaneously. And that's where we also can easily scale Spark and the execution just by adding a bigger worker. If we have coded well and we have enough partitions, we can quite well scale and execute everything way faster. And with that, let's now deep dive into the Spark UI and VSCode. So stay excited with it. Few hints in advance. So if you're running Spark locally and not on Databricks, for instance, you might need one of those links to access the Spark UI. So in our case, I already opened it and we can see here the Spark UI where no job has been running yet. Also, what we will not do today is like deep dive into the Spark UI. That's something I would spare for another session, but step by step in the next episodes, we're gonna use some parts of the Spark UI to already discover how Spark is working in the background. Then to better identify what's happening in the background, we're gonna use the Spark context .set job description, and then whatever you write there gonna be shown up in the job descriptions later on. This we're gonna see already today in the Spark UI, and even if the focus is not partitioning today, also to mention that we're gonna use a few times today in the next episodes SDF RDD get number of partitions to just see how Spark is actually partitioning our data. Last but not least, for evaluation purposes, it's usually recommended to use a noob. Right, so basically we are somehow have to execute an action. So write is an action, as you might already know. And doing actual writes, you usually have some storage optimization, etc. And the write noob is basically not doing anything in the background except of executing dummy action. By that, you can way better evaluate your code. So what are we doing? We are importing our PySpark session. These are already executed, and what we're doing is we are deactivating some Spark and Databricks optimization, in this case adaptive query execution and caching, just because we really want to see what Spark in the background is doing without all those optimizations, to just analyze it a little bit better. We have here a very simple data frame, which has 2 columns and 40 rows, 1 string and 1 integer column, and also checking the number of partitions. It's for already realizing in advance. We also have here, pretty much a single node cluster with 4 cores. That's why for this small data frame, we straight away have 4 partitions. More details on that also in the next session regarding partitioning. All right, so lazy execution, what does it mean? So in Python, if you would apply a filter, it would have been executed straight away in memory. But what you're gonna see here is if we are running a very simple filter on the data frame. Well, it happens in milliseconds, and also if you're going to the Spark UI, you basically see nothing really happened here. So we can't see any job. So, and that's pretty much what means lazy execution. So Spark is actually starting working once we have an action. And then the Spark execution plane in the background does its optimizations. It usually starts with the last transformation towards the first. And once we're gonna run here now an action, for instance, a count, we're gonna see now it's actually doing something. And hopefully in a bit we're gonna see the count. So we have, after filtering 9 rows, and now hopefully also we're gonna see here that we have our first job executed, and here you can see also the job description which we added manually. So that's what it means, Spark execution, and what, without going into detail, what the Spark execution plan also in the background is doing, you can pretty much see here, and also here in the details you can see in this case the physical plan, where you can see, okay, it starts from the back and then going to the beginning regarding the execution plan in the background. So going into also what you can see here is our partition number is pretty much staying even after the count is the same. So we can do the same thing with a loop, right? So if you're now basically not doing any transformation, we're gonna see also here that a write is a job, and we can see here that we have a new job added, which we called a loop write. So that's about laziness and actions pretty much. So there are of course other actions, but write and count, I would say, are the most common ones. Then about narrow transformation. So how can you identify it? How do you know that it's a narrow transformation? So first of all, let's execute the transformation and see what happened in the Spark UI. So a first hint for a narrow transformation is that the number of partitions, Spark partitions in this case, hasn't been changed. So you see it was in the beginning 4, and here we can see our initial data set had 4 partitions, and now we still have 4. And the reason for that is that each core in your cluster is executing 1 partition, and all those things are happening actually in parallel. And that's exactly what you're gonna see also in the Spark UI now, or you already saw it also without the filter, that we have 1 single job. So we don't have any exchange within workers, and we have 4 tasks, which are in this case equivalent to the number of partitions, which or generally equivalent to the number of partitions you have. Also, when we're going into the details, we see, okay, we have our stage 3, we can see the DRG graph, and theoretically we can also see here some more details about the stages. So let's find our filter loop right. You can see the stage details that we really have 4 stages, which pretty much run in 6 seconds each. So basically 1 stage without optimization, of course, and the number of partitions staying the same is pretty much an indicator that you have a narrow transformation. Another example, so we executed the count already before. is the count. So if you look into the Spark UI, you would assume, okay, that's a wide transformation. But what we're just doing is we are counting the data within the original data set. So basically we have no transformation, but you could say it's a narrow transformation, just with a count at the end. And actually, when we are jumping into the Spark UI, we're gonna see that this count operation actually executed 2 stages. So if we go to the DAG, we see that we have an exchange here. And also when we go into the SQL part and check for our count, gonna see that we have this hash aggregate and exchange here. I mean, the important part are actually the details, because you see that you have here partial count. So basically what count actually does is we are coming in with 4 partitions. That's what we, now I have to jump a little bit. That's what we saw here, that if we're going to our details, that our first stage were 4 partitions, and what each executor of those 4 did is it created a partial count. So let's say first executor creates 3, the second one 3, the third one 4, and the fourth one also 4. And then the one of those executors, so that's why we have this exchange, has to sum up all those values together. So 3 plus 3 makes 6, plus 4 makes 10, plus 4 makes 14. And that's how we are coming to the final count, which we're gonna have. And as you can see, here we have 14 in this case. Now it becomes a little bit more interesting. So now we have really a wide transformation. So in this case, we are running an aggregation about the column A, and while this is running, you can see that here we have 2 duplicates for the value A and B. So it's just counting up how many rows we have. And that's what you can see here at the end. We are just rerunning the data frame. And so how do you indicate that you have a wide transformation here? So one indicator is again the number of partitions. So it's 200, and the reason why is we have a parameter which is called Spark SQL shuffle partitions. So basically here you can define what's the number of partitions you're gonna have during the shuffling operation. And this usually depends on the number of data you're having in there. So without not going into details in this episode, but if I would now set the Spark shuffle partitions to 40, you're gonna see that the outcome of the partition is gonna be a 40. And I mean, you already guess it. Why do I need 200 partitions if I have only 12 rows here? It doesn't make sense, and that's why we have also something like AQE, which is dealing with it. Before running the same transformation with AQE, just to show you the differences, let's jump again back to our job with the wide transformation here. That's the one we can see. So you can see we have again an exchange here similar to before, and also just jumping back, we also have 2 stages. In the one stage you can see, okay, we have the initial 4 partitions, and then we have suddenly 200 Spark partitions, which is also the reason why we end up at the end with 200 200 tasks, and that's why we end up with 200 partitions at the end. And looking into the SQL tab again, and going to the physical plan, we're gonna see something which is called hash partitioning. So, and here we see that the 0 to 200 hash partitions which are happening during a shuffle operation. And that's pretty much the two indicators where you realize, okay, this might be or is a shuffle partition. Looking at the same thing with AQE, as we already realized, okay, 200 partitions doesn't make sense for 14 rows of data as an outcome. And you will also see, okay, you already can see from the previous execution, I did that the outcome for those few rows is actually one partition only. And that's how it actually should be for smaller data sets. And that's where AQE really gives you a benefit. It realizes that there are a lot of small partitions. Let's do a coalesce. So bring the partition, the data of multiple smaller partitions together to create a more efficient process. And if you're going back to the Spark UI, we will see under jobs, I called it wide AQE in this case. We see even two jobs, so it's separating it pretty much. So here we see the same as before, but in the second job we see the first job skipped and then see the AQE shuffle read. And the same thing if you're going to the SQL part, we're gonna see that we have here shuffle read, which is doing this coalescing of the partitions, as already mentioned. And again, we're gonna continue with our execution plan. And that's it for today's session. So thanks a lot for listening. I'm gonna share the link with the code. And of course, as always, feel free to subscribe, and more Spark videos are coming. A good afternoon, and hopefully hear you soon in the next session.